Now folks, we are going to talk about DHCP. DHCP are the dynamic host configuration protocol is designed to provide an IP address quickly and dynamically to hosts that appear on the network. Essentially, you define a range on the server of addresses that can be served. And when a client boot up, he will send out a request via broadcast message, and the server is going to lease him an address. Now there are two very common DHCP attacks. One of the host is called a DHCP insertion attack, where a rogue DHCP server appears on the network. This is pretty easy to do. You just install maybe a little Raspberry Pi with a DHCP server and plug it in under a desk somewhere. Once a false IP address has been given out to a client, it creates a man-in-the-middle attack, and we can capture packets that are sent from that client proxy them to the internet. The client won't know that they are connected to a rogue DHCP server, but it is real easy to capture all of their traffic. Another common attack is the DHCP starvation attack, in which a client will send out a number of DHCP requests to a server asking to receive an address. The server will send responses back because each of those requests is going to be spoofed from a different MAC address, so they appear to be different devices. And eventually the server run out of addresses in that range that was defined on the server, and it cannot serve DHCP to real client. And eventually the server run out of addresses. Because these are common DHCP attack, they are very easy to initiate. As a security analyst, it is important to understand these attacks and how the DHCP process should look. DHCP is a four-step process. It involves a client sending a DHCP discover message, the server responding with an offer. The offer will contain an IP address and some other information. That client will send a DHCP request. We say, yes, I want to use that address. And then the server will complete the process by sending a DHCP ACK, and that reserves the IP address for the client, and that reservation is valid until the lease expires. So on your topology, here we have a client who has come into a network. That client is going to go ahead and send a DHCP discover message, and now this is a broadcast to the destination is all once, and anybody that is on the network is going to hear it. That server, once it hears the DHCP discover message, is going to look to see if it has address space in that range that it can serve to. It will go ahead and send a unicast offer message directly back to the client. The client responds back with a request message saying, yes, please let me have that address. And the server complete the process again with an acknowledgement message, that is the DHCP ACK, and that finalizes the exchange. The UDP port number is 67 as the destination port for the server. So when this message leaves the client and leads towards server, we are looking for port 67, and that is UDP based. The server, as it replies back, it is going to be replying back to UDP port 68. So the source port is 68 and the destination port is 67, and that is in the view of a client to a server. All in all, DHCP is a simple process, but again, if it is used in the wrong way, it is easy to create a man-in-the-middle attack. And as an analyst, we want to be able to identify this. So next is DNS. Stay tuned.